Okay, Trig. I put the big Trig letters up here so you can find this video on my photos easier when you go to find videos and put it up in class. So hopefully that helped. Yesterday, where we got through the notes, you should have been able to get through 58. So hopefully you did. So we got like 4 problems left, but we still have quite a bit of examples left, I think, in the notes. So let's scroll on down to, I don't know, we are right here. Now we're going to be talking about domain. Okay, so composing functions. All right, let's talk about in example 6, when we had like stuff that looked like this, right? G parentheses F parentheses -3. That meant, that's another way of saying GOF, right? GOF, okay? Open circle means compose. So when I have a number here, I can take that and plug it into the F function and then take that information and plug it into the G function, right? So I plug that into F and then I take the result and plug it into G. But we talked about how if we don't have a number, like if we just have X here, this means, and they might write it like this, this means I'm taking P of X and I'm plugging that whole thing into M, right? That whole function into M. All right, here we go. So I'm taking P of X, that's the inside, and I'm plugging that whole thing into M. Oh my heaven's sakes. Okay. All right, here we go. So, and then we want to write the domain. All right, okay, so I'm plugging that in there. So it was originally 1 over x minus 5. And now I'm taking the square root of x minus 2 and plugging that in. Oy vey, this is gross. I cannot put these two together, right? -2 and -5. So I'm just going to write my final answer as the square root of x minus 2 minus 5. Okay. All right, now we've got to decide domain. Okay, so this is my final result. Now we have to talk about domain. We have to figure out what the domain is. Like, what am I allowed to and what am I not allowed to plug in for x? All right, so far, when my number line goes, I can plug values in for x, and I just have to figure out, like, what's going to give me a problem. So the 2 problems that we encounter, I call these domain errors, and I know you've written this down before. I don't want to divide by 0, and I don't want to have a negative inside of a square root. So let's do the second one first, right? If we have this second one right here, okay, I don't want to have a negative inside of a square root. So right here, as far as this guy goes, like, what am I allowed to plug in for x? What am I not allowed to plug in for x? Well, if I plug 2 in for x, I will have 2 minus 2, which is 0. But I can take the square root of 0, right? I can plug 3 in for x. 3 minus 2 is 1. That will work, right? But what I can't do is plug, like, let's say 1 in for x. 1 minus 2 is -1, and I can't take the square root of a -1, okay? So the deal here is 2 is my threshold. If I do 2, we said we could plug in 2. That worked, right? But I cannot plug in numbers that are less than 2, right? Like 1 or 0 or anything like that. So I can plug in 2, and it has to be a number that's bigger than 2. Has to be numbers that are bigger than 2. Okay, and that checks off problem number 2. That addresses this guy. We're good. Okay, but we also have to address this top one where we're dividing by 0, because I have a bottom also. Okay, so I don't want this bottom to be equal to 0. How in the heck do I solve that thing, right? Well, I'm just going to do this. I'm going to say the square root of x minus 2 minus 5 can't be 0. And then let's just solve for x, right? I'm going to add the 5 over. The square root of x minus 2 cannot be 5. And if I square both sides, right, to get rid of the square root, x minus 2 cannot be, is that 25? 25? And then I add the 2 over. So x cannot be 27. Okay, so here's the deal. We knew that x had to be greater than 2, right? Like from here, x has to be bigger than 2, but we can't have 27, right? Like x can't be 27. So it can be any number from 2 to 27, and it can be any number from 27 and beyond, but it can't be 27 exactly, all right? So how the heck do we write that in interval notation? Well, we have 2 like little loops going on here, right? Okay, so I have 2 pieces unioned with 2 other pieces, right? Like what's over here? This is going from 2 to 27. This one's a bracket, this one's a paren, right? And then we're going from 27 to like whatever lives over here, which is infinity, right? Paren. This is what he will look like. That is super disgusting. I hope the examples that you have to do on your homework assignment are a little bit nicer than that, because that one we had to address both of the problems going on, and that was super gross. Yuck, 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 yuck. Okay, so composition functions and domain. Usually you will only have to do one of these at a time. That one we had to do both. Ugh, gross. Okay, all right, moving on. What do we got left? Okay, all right. Example 9. Write the domain of the interval, in interval notation. So K composed of M of X. All right, which one's the inside? M is the inside. He's going into K, all right? So K, oh my gosh. Okay, K was X over X minus 2. All right. And I'm putting M into that, right? I'm putting this in here and here. So 6 over x squared minus 1 and 6 over x squared minus 1. Oh my gosh. Okay. All right. I'm going to go through this, and you're not going to have anything as ugly as this on the homework. We're going to pray, right? All right. Okay. Just bear with me. If you want to just watch, you can just watch, because this is going to be disgusting. All right. I want to find... out of this stuff on the bottom, I'm going to address this first. I want to find a common denominator. Cool. I'm going to put him over x, my common denominator. Right now, he's a denominator of 1, right? Okay. Whoa, where'd he go? He has a denominator of 1 right now. So I need that to be x squared minus 1, right? But if I multiply that to the bottom, the top needs an x squared minus 1, okay? So this, if I distribute, is negative 2x squared plus 2. And then I've got the 6 to combine with it. Okay, so here's what I've got going on. Just bear with me. 6 over x squared minus 1. And then on the bottom, if I combine these together, I've got, I'm going to put them in order, negative 2x squared plus 8 all over x squared minus 1. Okay, all right, we did our common denominator thing. We put them all together, whatever. Now, I'm going to flip it to the top. Okay, all right, we can do this. Times, this is not actually going to be as unpleasant as I thought. X squared minus 1, and then I've got negative 2x squared plus 8. I just flipped those to the top, and then the exciting thing, these two are going to cancel. So, final answer after I simplify all of the junk is 6 over negative 2x squared plus 8. Now, here's the deal. I have to find the domain, like what can x be, what can x not be. So rule number 1 says we can't divide by 0, and rule number 2 says negative inside of a square root. We do not have any square roots, so we don't have to worry about that one. I just want to make sure I'm not going to divide by 0. So in other words, this thing right here cannot be equal to 0. Can't be, all right? So I'm going to set him not equal to 0. I'm going to say negative 2, x squared plus 8 can't be 0, and then I'm going to solve. I'm going to subtract the 8. So I've got negative 2x squared, can't be negative 8. If I divide by negative 2, oh, gross. X squared can't be 4. Okay, no, that's not too bad. If I take the square root, x cannot be, the square root of 4 is plus and minus 2. So I cannot have values that are plus minus 2. And they want interval notation? Okay. All right, oh my gosh, you guys are going to go crazy about this. All right, negative 2, positive 2. It cannot be 2 and negative 2. So that means I have like open circles here and here, but it can be any number this side, it can be any number here, and it can be any number that side. How do I write that in interval notation, right? You're going to have 3 pieces. All right. So left to right, the number that lives over here is negative infinity with a paren, up until we get to negative 2 with a paren. Then we're going negative 2 to 2, paren, and then we're going 2 to infinity, paren. That is interval notation. That was really disgusting. Okay, I am okay with you putting it as this for your domain if you want to. I am fine with that. Just because that interval notation makes it even worse, but just so you know, that's how you write it, okay? So, there you go. All right, couple left. Oh my heavens, couple left. All right. At a popular website, the cost to download individual songs is $1.49 per song, okay? In addition, a first-time visitor has a one-time coupon for $1 off. Okay, so write a function to represent the cost for a first-time visitor. So they call it C of X, okay? for a first-time visitor to purchase X songs. All right, so it's going to cost me $1.49 per song, but I get $1 off. So I'm going to subtract that $1 for a first-time person. Okay, the sales tax now for online purchases depends on the location of the business and customer. If the sales tax rate on a purchase is 6%, write a function to represent the total cost for a first-time visitor who buys $8 in songs. Ugh. Sales tax rate on a purchase is, okay, so sales tax, I think T of A will just be, sales tax, if it's 6% tax, we have to add it then back to the original. So it won't just be 0.06 times whatever you purchase, right? It will be 1.06, right? Times X, where X is, or no, we'll go A, where A is the number in dollars I spend, right? Now, here's the deal. When we do this, right, when we do part C, they want us to plug this, because C of X is the inside function. They want us to put this in here, right? Because what I'm doing is I'm calculating the amount of money I'm spending before I multiply by 1.06. That's like how it is in the real world. Like that's typical of what happens. So find T composed of C of X. If I plug that in there, I gotta write small. T composed of C of X is equal to 1.06 times A. And A is now 1.49x minus 1. Okay, so I'm calculating the amount of money that I'm spending and then multiplying by the tax. Okay, and then if I distribute that through, let's make that look a little nicer. 1.06 times 1.49. 1.06 times 1.49, and that is 1.5794 x minus 1.06. So that is what that is. And then before, when we had like T composed of C of 10, I would plug 10 in for C and then plug that number in for here, right? So typically we would plug 10 in and find my cost and then take that cost and calculate the tax, right? But here, since I already have it written T composed of C of X, I can just get away with plugging 10 into there. And if I plug in 10, that's just going to be the decimal. So this is going to be 15.794 minus 1.06. And I can do that in my head, I think. 14.734, which round to the nearest tens place because pennies don't go more than that, will be $14.73 for doing 10 songs. It's 10 songs? 10 songs. Purchases X songs. Oh, okay. Okay. And interpret the meaning of the context. I didn't do that for part C, but we'll do it for part D. This is the cost for 10 songs. That's my interpretation. Interpret the meaning and context. There we go. Okay. All right. Oh, this is my favorite. Okay, example 11, example 12 are probably my favorites, actually. This one is saying, here is what h of x is. Okay, I want to decompose, which means I want to break that apart into two functions that are happening, okay? And I want to like pull it apart so that I can write it as f composed of g of x, okay? So f of x has to be like my outside operation, and g of x is what's going inside of that, okay? So like my outside operation looks like the absolute value of x, right? Okay, and inside that absolute value, inside of there, I'm plugging in 2x squared minus 5. So I could write it like that, right? F composed of g of x means I'm taking this guy and I'm shoving it in there, right? Another thing that I could also do, so there's multiple answers to this. Another thing that I could do is, let's say f of x, let's see if this works. Let's say if f of x is x, the absolute value of x minus 5, and g of x is 2x squared. If I take this guy and shove it in there, will that give me the same answer? Yeah, like I could do that, right? Okay, or another, I won't do too many more of these, right? Another one I could do is the absolute value of 2x minus 5, and I could say g of x is x squared, right? And I'm shoving that into there. That's another combination that I could do, right? This one's probably the most obvious one, but I have other options as well, right? And not always do you have like a bunch of options, right? Sometimes you only have one main thing that you could do, but any of these would work as well if we did f composed of g of x, right? So it's decomposing functions, like breaking them down into two things. We do that a ton in calculus when we start looking at derivatives. We're like trying to figure out what operation is going inside of another, and like this tool, like decomposing functions, is super handy when we start doing derivatives. If you're not taking calc, you don't care probably, but anyway, that's like that mentality, that brainwave is like where we go with derivatives and stuff. So, okay, example 12. Using the graph. The graphs f and g are shown. The blue one is f of x, the bottom one is g of x. Got it. Okay. They say, what is f plus g of 1? Okay, now let's do this. F plus g of 1 means f of 1 plus g of 1, right? Like that's what I'm doing, all right? So I'm going to find f of 1, which means if I go over to 1 on the x-axis, the f value is 4. So f of 1 is 4, right? If I go to 1, the g value is -3. And I'm adding those together. 4 plus -3 is 1. Cool. Next. All right. This one is f of 0 times, right? That's what that means. Times g of 0. So I'm going to find these individual values. 0 lives here. The f is 4. The g is -4. So I'm doing 4 times -4, which is -16. That's what f times g of 0 is. Okay? Next, this is minus. So we're doing g of -3 minus f of -3. Okay, I'm going to -3 on my x-axis. Oh, gosh. Oh, gosh. G of -3 is this guy right here. He has -1. But problem, minus f of we don't have an f value at -3 because it's open circle. How the heck does that work? F of -3 does not exist, so nothing exists. The whole thing doesn't come out with a solution because even though g had a value, f doesn't have a value because it's an open circle, so that doesn't work. Interesting. Okay, next, these ones are compositions, okay? So these three are treated a little bit different than these guys. These guys, you kind of do them separately and then put those values together at the end. These ones you're going to do like one after the other. So we start with the inside function, and I'm going to find g of 3 first. Okay, so I go over to 3 and I go down to g, and g of 3 is -1. So here's what I'm going to do. If g of 3 is -1, now I'm going to find f of -1. So I'm going to go to -1 on the x-axis, and f of -1 is +3, okay? Before you were taking this value and plugging it into g and plugging that into f or whatever, and then like putting them together, now you're going to have a different value that you're going to evaluate the second function, okay? Let's do the next one. I want to find f of 4 first, so I'm going to go to 4, and f of 4, he's crossing his y-coordinate is 0. F of 4 is 0. So I want to find now what g of 0 is. So if I go to 0 on the x-axis is here, the g value is going to be -4. So g of 0 is -4. So my final answers are those guys, okay? A little bit different than what we were doing up here. Here we were plugging the same number in on both graphs and either adding them together, multiplying them together. Different this time, okay? This is f composed of g of 1. They just didn't write it as fog. They wrote it as parentheses, which is fine. We want to first find what g of 1 is. So I'm going to go to 1 on the x-axis, and I'm going to go to g, and g is -3, okay? So now I'm going to do f of -3. I go to -3 on the x-axis, and my f is supposed to be here, but he doesn't have a value, so he has no solutions. Okay, all right, that kind of has like some weird stuff going on, okay? So hopefully that made sense to you. If you still have questions, I can help you with those tomorrow or whenever we come back together, but chapter review next, oh my gosh. So you have, I think, 4 problems left, hopefully. Yeah, there you go. Okay, use the rest of the time to work. If you want to compare answers, check together, I don't care, whatever. Goodbye.